Okay, couple ways to go about starting this one off. Me personally, I'll try to minimize the amount of things to memorize. I know it's base 4, and I know what 4 to the x looks like. So log base 4 to the x is an inverse of that. So I'm going to start with just the exponent points, since we've just practiced a bunch of those. It's -1 a fourth, 0, 1, and 1 comma 4. So to find the inverse, I just switch the order. So the parent points are a fourth comma -1, 1, 0, and 4, 1. Okay, so then I can look at what my mapping rule is. So for all of the x's, we are going to add 2, and for all of the y's, we're going to subtract 3. Okay, so 2 and a fourth, comma, -4. That would be 3 comma -3, and this would be 6 comma -2. Okay, and oh, the asymptote, we didn't do the asymptote. Okay, so it's for exponential, it's y equals 0. For log, it's x equals 0. So in this case, all the x's got added 2, so we're now at x equals 2. All right, so we'll do the asymptote first. Then let's plot our point. So 2 and a fourth, -4, so puts me right down there. 3, -3, so 1, 2, 3 right there. And 6, -2 puts me right there. Okay, so I can kind of see what this graph is doing. Looks about like that. All right, 16 and 17, we are rewriting from the form it's in to the other form. So if it's a log x equals 2, I need the base. So if I don't see a base, then it's base 10. And then remember, x and 2 switch places, so it's 10 squared equals x is the exponential form of that statement. Exponential form to log form, all right, so I need a log base. What's the base of the exponent? Well, that's 2. Remember, the two numbers switch places. Equals -1. And that one's done. Okay, then we have several simplifying exercises. So this would be log of 50 times 200. Well, let's see, 5 times 200 is 1,000. So 50 would be 10,000. And, log by itself is just log base 10. So I need some exponent of 10 that equals 10,000. And that would be 10 to the 4th. And so now that I got the log and the 10 to match, then it simplifies down to just the exponent. Log base 4 of 16 to the 100 power. So 16 is really 4 squared to the 100. So log base 4 of 4, multiply those exponents together. So I get to the 200, and since that's one of my log properties, so the answer is just 200. Log base 5 of the square root of 5. So log base 5 of 5 to the 1/2. And again, that's one of our properties. All right, 1/4 log base 3 of 81. I'm going to bring up the 1/4 as an exponent. So log base 3 of 81 to a 4th. So I need some number that I can multiply 4 times in a row to get 81, and that's 3 actually. So this would be the 4th root of 81 is actually 3. And that statement actually simplifies down to the number 1. It's one of our log properties. Okay, so expand the log out. I'm looking for any multiplies and divides. So first thing I can do is I can split it up to subtraction, and I'm also going to rewrite that square root as a 1/2. So log base 3 of 3x to the 5th to the 1/2 minus log of y. And I can bring the 1/2 out front. So 1/2 log base 3 of 3x to the 5th minus log of y. And inside I'm multiplying, so I can split that up as another sum. So 1/2 log base 3 of 3 plus 1/2 log base 3 of x to the 5th minus log y. Now log base 3 of 3, that's actually 1. So we got 1/2 times 1, so that's 1/2 plus, and that 5 I can bring out front, 5/2 log base 3 of x minus log base 3 of y. I just realized I need to do log bases 3's with those y's. And that is actually a perfectly good answer. Alright, next door we got condense it down to 1 log. So log statement. I see a minus, so I'm going to bring that as, that means I'm dividing some at some point. And let's kind of do this term by term. So 4 log x, I bring the 4 up to the x, so that goes up in the numerator. The 1/3 I bring up, and the minus says put it in the denominator. So, and the 1/3 actually means cubed root of x squared plus 1. And then that 2 I can bring up, and it's back to plus, so now we're up in the numerator again. So x minus 1 squared. And there's our lovely, lovely complicated looking answer. Alright, number 19, we are solving a series of equations. Alright, so this first one is a common base one. So I can rewrite 27 as 3 cubed, but to the negative power since we're dealing with a fraction here. So it's negative 1/3. It's equivalent to 1 over 27. Then I'll just set the exponents equal. Let's bring that over. So 2x, 1 plus, 1 minus 1/3 actually is 2/3. And then I want to divide by 2. So let me rewrite that real quick so I can show you what's happening here. Okay. So I get x equals, well, that's really 2 over 1. And the rule is if you divide by a fraction, you multiply by its reciprocal. 2's divide out, and so I'm left with 1/3. Okay, next problem, I'm going to bring the 4 over. So e to the x plus 3 equals 14. Then I will take the ln of both sides. That's actually a property on the left. That leaves us with x plus 3 equals ln of 14, and so then I just want to subtract off the 3. Okay. Next up, the log. So this would be 5 squared equals x minus 2. So 25, and then we'll bring the plus 7 over. So that means x is 32. And I do want to just check it. So 32 minus 7 does give me some sort of positive number. So I'm going to be careful with that. All right, last but not least, all right, so I want to combine them into a single log statement. So log base 3 of x minus 4 times x plus 4 equals 2. Then we'll convert to exponent form, so that's 3 squared equals x minus 4, x plus 4. Well, that's 9 equals x squared minus 16. Let's bring the 16 over. Why not? So that's 25 equals x squared. Then I want to take the square root of that, so I get plus or minus. So I get negative 5 and positive 5 as my two potential answers. Okay, now I just need to confirm that I don't violate any domain restriction. So when I get to x minus 4, that negative 5 being negative already makes that more negative. So that actually doesn't work. The 5 does work in both cases. So correct answer is 5 in this case. Okay, $4,000 is placed in a savings account at a rate of 5.75% per year. Compounded daily, find the amount after 7 years. Okay, so that's our compound daily formula. So I want 4,000, 1 plus 0.575, or compounded daily, so that's 365. And then raise that to the 365 times 7. And the answer is... Okay, sorry, I just caught a fairly bad math error, which is going to impact your answer. So let me kind of show you what I wrote that was incorrect. And maybe you didn't even catch it. So I'm just tattling on myself for no reason. 5.75% is really 0.0575 rather than 0.5%. I mean, you're making 57% a year. That's amazing. Okay, anyway, so the answer is, as soon as I type it in my calculator, okay, it's $5,982.05. All right, population has a relative growth rate of 3% a year. If the population is 100 million, find the population in the year 2052. Okay, so we're looking at PERT. So P equals P naught e to the RT. Our initial population is 100 million. E to the 0.03 times. And I just need to figure out what T is. Well, T in this case is 2052 minus 2011. Will tell us how many years have passed. That's 41. So to the 41st power. And type that in. You get, I will tell you. So we're going to get something like 342.12 million on that. All right, number 22, this is a double life formula. So if you remember, the general equation for a double life would be 2 to the t divided by the double time. All right, so in this case they're telling us we start off at 12,000 times 2. We're actually solving for t, and it takes 15 years to double. Okay, so that's the equation we're solving. So I need to get everything moved over, and so I can isolate out that t. So I'm going to start off with the 200,000 divided by the 12,000. So we'll divide both sides by 12,000. Nice part is those zeros cancel out. And 200 over 12, let's do a bunch of reducing here. I can divide by 2. I can go by another 2. Alright, that's about as small as we're going to get. Okay, so we now have 50 over 3 equals 2t over 15. So then I want to take the ln of both sides, So the ln of 50 thirds. And the reason why I do the ln is that allows me to bring the exponent out. Okay, so then I've got this nice lovely formula for t. So ln of 50 thirds. I'm going to multiply by 15, and I'm going to divide by ln of 2. And so that's a lovely exact answer. So if I want to get a decimal approximation, then I want, let's see, type that in, 15 times the ln of 50 thirds divided by the ln of 2. Okay, so I get about 60.883. So if I round up to the nearest year, it's about 61 years. All right, last question that I'll work for you. Roasted turkey is taken from an oven when its temperature has reached 185 degrees Fahrenheit and is placed in a room where the temperature is 75 degrees. If the temperature of the turkey is 150 degrees after 30 minutes, what is the temperature after 45 minutes? Okay. So we need to pull out the Newton's law of cooling formula, which is right there. And I need, let's see, first off I need to know the temperature of the surrounding room. That's our TS. So I get T of T. So what number represents the room temp? And that is, let's see, the place in the room is 75 degrees. Okay, then I need the initial temperature minus the room temp. So 185 minus 75, e to the negative. I don't know K yet, and I don't know T yet, but I mean those are, but this so far is the constants in the problem. All right, with problems like this, I typically am giving conditions so that I can find K, and then I can use that to actually figure out the question they want. Okay, so somewhere in here is a given time and a given temperature, and it's right there. Okay, so I'm going to plug that information in, which allows me to solve for K. So 150 degrees, 75 plus, and let's actually do the calculation real quick. 185 minus 75 gives us 110. E to the negative K times 30. Okay, so then we're going to solve for K. So 150 minus 75 equals 110 e to the negative 30k. Let's see, let's go ahead and subtract that also. So 150 minus 75 is 75. It's a rather convenient number. And I want to divide that by the 110, e to the negative 30k. Okay, so then I'm going to take the ln of both sides. So ln of 75 over 110 equals ln of e to the negative 30k, but, oops, sorry about that. Let's see, so ln of 75 over 100, ln of e, so ln e to an exponent just simplifies down to that exponent, and so k would be ln of 75 over 100 all over negative 30. Okay, so that's our lovely rate. I'm going to leave it in that exact form for a moment, and you'll see what I'm going to do with that in a second, but I like that form. Nothing wrong with that form at all. All right, I'm going to come back up to my original equation, and I'm going to rewrite this, because now I have that rate. Plus 110E, and I'm going to fill that rate in. So it starts off as negative, and it's a negative ln of 75 over 100 all over negative 30 times t. Okay, well, first thing I notice is the two negatives take care of each other. So a negative and a negative now make that positive, yay. And get caught up here, 110. Okay, so I'm going to, that exponent of e, as lovely as it is, I'm going to group the t and the 30 with each other. Right now it says ln of some number, and it's divided by 30, and it's multiplied by t. So what I'm going to do is I'm going to bring the t over 30 in together as a fraction. So that's t over, well, that's t over 30 ln of 75 over 100, right? Okay. Now, I'm going to do another step here. And the reason why I'm doing this is I can see a way to get rid of e's and ln's. If I can get it to say e to the ln of something, it's going to simplify down to that something. I'd like it to do that. Well, we have an ln property that says I can, if I'm multiplying by something out front, I can yank it up as an exponent. So let's do that. So that's e to the ln of 75 over 100, and that's now raised to the t over 30 power. So for a brief moment, just a brief moment, I've got e with an exponent of ln of a fraction, and that fraction has an exponent that's a fraction. Yeah, I hope we're okay with fractions at this point. We're not just, I hope we're not just stopping saying, oh, it's a fraction, I give up. Take a deep breath. What's the rule? Always think simple. What is the rule that we're trying to use? And I'm trying to use an LNE property. Right? I'm trying to get down to this statement right here, and I can see it. Okay? So 75 plus 110 times. Well, that just leaves me whatever the exponent is. So 75 over 100 t over 30. And so that's my new simplified equation, right? That's the new thing that I'm going to use to solve for whatever it is they want me to. Okay, so there's my, that question is, what's the temperature after 45 minutes? Okay. All right, so temperature 45 is 75 plus 110. 75 over 100, and that's 45 over 30. Okay, so at that point I just need to go to a calculator, and let's see, well, 45 over 30, that's just 1.5. And 75, I just realized my 110s look a lot like hundreds. Okay, that's a 110, that's supposed to be a 1, these are supposed to be 110s. Actually, no, they're not. They're supposed to be T's. Oh, they are supposed to be over 100. I'm sorry. I'm getting ahead of myself. Yeah, because I did subtract it off and get divided. Okay, so it is over 100. I'm sorry. I added a complication that didn't necessarily need to be there. I actually did it right, and I am just wanting to confuse people at the last second. All right, so 75 over 100 is 0.75, and I'm going to raise that to the 1.5 power. And that gives me 0.649 that I'm going to multiply the 110 by. And then I'm going to add the 75 to it. So after 45 minutes, I get 146.4, we'll go 5 degrees. Okay, so about 146, and the nice thing is, it makes sense in context. If it cooled down to 150 degrees after 30, so another 15 minutes, should be, obviously it can't be bigger than 150, so it should be something smaller, and it is. So, yay, math checks out. Awesome math. All right, well, good luck on your test. Hopefully this all helped.